So welcome you to today's lecture. So what we'll do tomorrow is we'll meet in L13 for our 11 o'clock class, and we'll take I'll take a lecture on experimental basis. It would be recorded on Zoom, so it would be available live also. So those who are not able to attend it may see it live, and then the recording would also be available. And let's see how does it work. If it works well, then from Monday onwards we can meet physically for our lectures. All right? Okay, so any questions you have from your last lecture? Any questions? Okay, if there are no questions, let me move. So what we were discussing last time was uniformly most powerful tests, and the formulation is as follows. So consider testing H0 that F belongs to P0 against that F belongs to P1, where P0 and P1 are two families of distributions such that they are disjoint, and their union is the class of all PDFs or distributions under consideration. And suppose I want to test this at alpha level of significance, where alpha is a quantity strictly between 0 and 1. So I have to find a test phi star whose level is alpha, that means whose size is less than or equal to alpha. And if you take any other test whose size is less than or equal to alpha, then the power of the test phi star is larger than the power of test any other test phi, which has level alpha. I'll call such a test to be uniformly most powerful test. Then we noted that if one is looking for a uniformly most powerful test, one can consider only those tests which depends on observations only through sufficient statistic T. So suppose that T is a sufficient statistic, then given any test function phi, I define a new test function phi star T, which is expected value of phi x given T. So note that since it is conditional expectation of phi x given T, it will depend on observations only through T, because here it is for every fixed T, phi star is defined in terms of this conditional expectation. Clearly, phi star does not depend on any unknown parameter because T is sufficient. So conditional distribution of x given T is independent of theta. So this expectation would also be independent of theta. So clearly phi star depends on T alone, and by virtue of sufficiency of T, it does not depend on unknown F. So it is a proper statistic. It does not have any unknown parameter. So thus, and this is also between 0 and 1, because phi was a test function, it was between 0 to 1, so its expected value would also be between 0 to 1. So it is a proper test function. When I looked at the power function of this beta phi star F, which is expected value of phi star T, which is expected value of phi x given T. And you know that expectation of a conditional expectation is same as the expectation of the corresponding thing, which is phi x, which is same as beta phi. So what does it say? That given any test statistic phi or test function phi, I can find a test function which is based on sufficient statistic T, says that the test function phi star, which depends on T, and phi have the same power function. Now, if they have the same power function, then that means the level and everything, if it satisfies the level supremum beta phi f is less than or equal to alpha, then supremum under h naught of beta phi star f would also be less than or equal to alpha. And if it is uniformly most powerful, this would also be uniformly most powerful because they have the same power function. So this discussion suggests that to find UMP alpha tests, one may consider tests that are functions of minimal sufficient statistic T alone. Now let me define what do you mean by a simple hypothesis and a composite hypothesis. A hypothesis H naught, which is a null hypothesis, or the alternative hypothesis H1, is said to be simple if and only if, in the case of H naught, I'll call H naught to be simple if P0 has only one element. So that means P0 has exactly one PDF or PMF. Similarly, I'll call H1 to be simple, alternative hypothesis to be simple, if the family of distributions described under H1, which is P1, has only one element. Or in other words, I'll call H0 to be a simple hypothesis. I'll call a null hypothesis to be a simple hypothesis if under null hypothesis, the distribution is completely specified because H naught has only one PDF. So we know exactly what the PDF is. Similarly, if under H1, P1 has only one element, that would be called a simple hypothesis. Otherwise, a hypothesis which is not simple will be called a composite hypothesis. Let us look at this example. Suppose I have a bivariate random vector x1, x2, which has a bivariate normal distribution with common mean mu, so mu mu. Variance is 1, 1, and correlation coefficient rho, rho, rho. So suppose my null hypothesis is H naught that mu is equal to 0. Is this a simple hypothesis? This would be a simple hypothesis if under H naught there is only one PDF. But I see my PDFs involve two parameters, mu and rho. So even under H naught, mu is known. The only thing I know is X has PDF and 2, 0, 0, 1 row, row 1, but row may vary. So H naught mu is equal to 0 would be a simple hypothesis only when row is known. If row is also unknown, then this is not a simple hypothesis. So this is a composite hypothesis. So this is a composite hypothesis if rho is not known. So I do not know completely the value of rho, and this would be a simple hypothesis. If rho is known, because if rho is known, then at H naught, mu is anyway, value is given to be 0, 0, and this rho is a known quantity. So the PDF is completely known. That means it is a PDF of a bivariate normal distribution with mean 0, 0. Covariance matrix has 1 row, row 1, where rho is known quantity. So now let us do this famous lemma, which is called the Neyman-Pearson lemma, which is helpful in finding the uniformly most powerful test for testing simple hypothesis against simple hypothesis. So consider testing simple null hypothesis f is equal to f0 against simple alternative hypothesis h1 that f is equal to f1, where f0 and f1 are known PDFs. So here the class of PDFs which are under consideration is only two PDFs, f0 and f1. So my P consists of only f0 and f1. What is the distribution under f0? H0, which is P0. So under P0, I'm saying my f is exactly same as f0. So my P0 consists of only one element, which is f0. What is my PF? P1? P1 is the family of PDFs under H1. Under H1, I'm saying my f is exactly same as f1. So my P1 is also containing only one element, which is f1. So here, since f0 and f1 are completely known, P0 and P1 are single tests. So they have only one element. And that's the reason why I call this H0 to be a simple hypothesis and H1 also to be a simple hypothesis. So this Neyman-Pearson lemma tells you to find the uniformly most powerful test for testing F is equal to F0 against F is equal to F1. So consider testing the simple hypothesis F is equal to F0 against simple alternative hypothesis that F is equal to F1. The first part of the Neyman-Pearson lemma says there exists a UMP alpha test. So for any alpha strictly between 0 to 1, there exists a UMP alpha test which is given by this. 1, if f1x is greater than c times f0x, gamma, if f1x is same as c times f0x, 0, if f1x is less than c times f0x, where gamma belonging to 0, 1, so gamma can be 0 or 1 also, and c greater than or equal to 0 are constants which satisfy expected value of f0, phi star x equal to alpha. So here, c is equal to infinity is also allowed, right? So 1 if f1x is greater than c times f0. So technically speaking, one can choose c to be infinity also, and one can choose c to be 0 also. So c could be anything from 0 to infinity in the extended real number system. So there exists a UMP alpha test which will have this structure, and this constant c is chosen, constant c and gamma are chosen so that this has level of significance alpha. Now, if phi double star is UMP alpha test, then it has to be of this type, except on this set, f1x equal to c times f0x. So it says if you look at any UMP alpha test, it is 1 if f1x is bigger than c times f0x, and 0 if f1x is less than c times f0x. So any UMP alpha test would be of the above type, except on the set f1x equal to c times f0x. That is, UMP alpha test can essentially differ only on the set of all those x's, such that f1x is equal to c times f0x, where c is greater than or equal to 0. So first I prove that there would exist constants gamma and c such that E of f0 f star, phi star x would be alpha. Right? First I have to show that such a test exists, and then I'll show that such a test is uniformly most powerful alpha test. So first I'll show the existence of such a test having this structure and satisfying E f0 f phi star x equal to alpha. And then second step, I'll show that such a test is uniformly most powerful alpha test. So let us look at what is expected value of this quantity. Expected value of this quantity is 1 times probability that f1x is bigger than c times f0x plus gamma times f1x equal to c times f0x. So I look at E f0 phi star x. So first I'll prove that there exists gamma belonging to 0, 1 and c greater than or equal to 0 such that this holds. So let us define beta t to be probability that probability under f0 that f1x is greater than t times f0x. Because if you look at this quantity is equivalent to saying that probability that under f0, because phi star is 1 if f1x is greater than c times f0x, gamma if f1x is c times f0x. So its expected value under f0 would be probability under f0 that f1x is greater than c times f0x plus gamma times probability that f1x equal to c times f0x. So this is same as p under f0x, that f1x is greater than c times f0x plus gamma times probability that f0 that f1x is same as c times f0x. This is equal to alpha. So I have to make this equal to alpha. So now note that if this quantity is alpha, then this quantity has to be less than or equal to alpha. Right? This quantity can be at the most less than or equal to alpha. Because gamma is positive, this probability is positive. So when you add something in this, then only it becomes alpha. So that means this quantity has to be less than or equal to alpha. So first, I try to reach near alpha through this term only. So I study what is this term. So I call this as a beta t as a function that p of f0, f1x is greater than t times f0x, because I have to find what this is, which is same as 1 minus probability that f0 of f1x is less than or equal to t times f0x. Now note that this is kind of a distribution function. If I suppose f0 division by f0 was allied, this is same as f1x by f0x is less than or equal to t. So this kind of a distribution function of f1x by f0x, provided this division by f0x is allowed, that would be allowed at all the points where f0x is different from 0. So it is like a distribution function. This will have all the properties of a distribution function as a function of t. So non-decreasing in t, right continuous in t. So if this is increasing in t, so 1 minus would be decreasing in t. So beta t is a decreasing in t belonging to 0 to infinity. T is equal to 0 and t is equal to infinity allowed. Distribution function is right continuous. So 1 minus that would also be right continuous. Let us look at what happens when t goes to infinity. T goes to infinity, which is beta plus infinity. What would be this quantity? As t goes to infinity, this will become 0, right? Because this will become 1. And when t goes to 0, sorry, this is t decreasing to 0. This I should write down as t decreasing to 0, which is beta 0. Beta 0, sorry, t increasing to 0 is okay, because I'm looking at what happens from the left. So beta 0 minus, which is same as limit t going to 0 from left of beta t. If t is going to 0 from the left, then this quantity would be same as f1x is less than or equal to 0, right? 0 kind of a thing, and that probability would be 0. So that should be 1, because our density is always positive. So thus, this quantity, I can vary anything from 0 to 1. So that way there would be a C such that this alpha would be between beta C would be less than or equal to alpha, because I want this quantity to be less than or equal to, so beta C less than or equal to alpha, and this is less than or equal to beta C minus. So I define, if so there is a jump, so it is like this. So you have considered this quantity, right? You have considered this quantity. I know that this is t, this is beta t. Beta t may be a step function, it is a distribution function. So it is a decreasing function. So it may be like this. It is a decreasing function. And your alpha may be somewhere here with me. Right? And now this quantity has to be less than or equal to alpha. Right? So I move up to this point. This may be my point C. And this may be my C minus. So my alpha may be between beta C and beta C minus, right? Because it is decreasing. So I keep on starting from the top and C until what time it remains less than or equal to alpha. It remains less than or equal to alpha at this point. Sorry, not this is C. This is C. And this may be my C minus. Right? This may be my C. So if alpha was exactly same as this quantity, then I could have taken this as a C. But in general, alpha would be between beta C and beta C minus 1, and there may be a jump over here at this point. So I look at the size of that jump, and I use this gamma to fulfill whatever is left in achieving this alpha. So I choose gamma to be alpha minus P f0 f1x greater than C times f0x, so which is alpha minus beta C upon beta C minus 1 minus beta C, right? Which is basically same as probability that f1x equal to C times f0x. So that is a denominator. But that is the case only when there is a jump. when beta c minus is not equal to beta c. And if there is no jump, if this alpha is exactly same as this, then I take my alpha to be exactly same as c. So then in that case, my gamma becomes 0. So my c I choose such that beta c is between less than or equal to alpha and less than or equal to beta c minus 1. And gamma to be this. If that happens, then I know that beta c minus 1 minus beta c is same as probability f1x is same as t times f0x. And E f0 phi star x is same as probability f0, probability under f0 that f1x is greater than c times f0x plus gamma times probability f0, probability under f0 that f1x is greater than c f0x. So the idea is very simple, because what you're trying to do is you're trying to satisfy this. Now, after I satisfy this, I know that how should I find for c? I realize that this beta t function, which is only taking the first part, it is a decreasing function of t. So if I take t going to infinity, this quantity is going to be 1. That is not going to work because this itself is 1, so I have to go to alpha. If I have to go to alpha, this quantity has to be less than or equal to alpha. So I move from t is equal to infinity when this value is 1. I keep on decreasing t, and I know that when t is going to 0 minus, then this probability becomes 1. So somewhere it would cross alpha because it is a right continuous function. So I look at that c such that my beta c is less than or equal to alpha, which is 4. Beta c is less than or equal to alpha. And alpha is less than or equal to beta c minus. So this is the point. So alpha is lying somewhere in between. So that becomes c, and this gamma then is used to fulfill whatever gap is left between alpha and this quantity, which would be nothing but alpha minus this quantity, which is beta c, divided by probability of this, which is same as beta c minus beta c. So I have proved that there would exist gamma and alpha such that for phi star expected value under f0, I get as alpha. And the second step, I proved that phi star is uniformly most powerful alpha test. So let phi be any other test at significance of level alpha. What does that mean? That means expected value under f0 phi x is less than or equal to alpha. Then what I have to show? I have to show that the power of this test would always be smaller than the power of test phi star. So I consider delta x, which is phi star x minus phi x, into f1x minus c times f0x. First of all, note that this quantity would be greater than or equal to 0 almost surely. Why? Because phi star depends on 3 reasons: whether f1x is bigger than fc times f0x, or f1x is same as c times f0x, or 0 otherwise. In this reason, f1x greater than c times f0x, this is 1, this is gamma, and this is 0. So let us look at this quantity. This quantity would be how much? I can again consider it into 3 sets. f1x is greater than c times f0x. Then anyway, this is positive because f1x is greater than. Phi star in this case I know is 1 minus phi x into some positive quantity, because f1x minus c times f0x is positive. So this is greater than or equal to 0, I know, because phi is a test function, so it will always be less than or equal to 1. Now, if f1x is same as c times f0x, then what happens? Then anyway, this is 0 because the second quantity itself is 0. Now, when f1x is less than c times f0x, I know that in this case phi star is 0 minus phi x would be some quantity into f1x minus c times f0x, in this case is negative. So it is negative, negative, positive, 0, and positive into positive is positive. So this quantity, delta x, would always be greater than or equal to 0, almost surely. And I know that if a function is non-negative, its expected value would also be non-negative. So integral over phi star x, phi x, f1x minus c times f0x dx would be greater than or equal to 0. Okay? Because your P is f0 union f1. So under P is basically containing both f0. So phi star x minus phi x, f1x minus c times f0x would always be greater than or equal to 0. So I look at this quantity. What does that mean? Integral f1 times this quantity means expected value under f1 of phi star x minus phi x would be greater than or equal to c times expected value under f0 of phi star x minus phi x. Expected value under f1 of phi star is beta of phi star f1, which is the power probability of rejecting h0 when alternative is true, minus beta phi f1, which is probability of rejecting h0 using test function phi, is greater than or equal to this quantity. What is E f0 phi star x? We have seen that this is exactly same as alpha. And since this phi has level alpha, so E f0 phi x is less than or equal to alpha. So this is exactly alpha, this is less than or equal to alpha. So that, and C is positive, so this would be greater than or equal to 0. So this proves that power of phi star would be bigger than or equal to power of phi, which means phi star is UMP alpha test. This proves the part 1. Let us prove the second part, that any UMP alpha test would differ from phi star only on the set f1x equal to c times f0x. That is what you have to show in the second part. That means if you look at any other UMP alpha test, that would be exactly of this type. It may differ only in this set gamma. Gamma if f1x equal to c times f0x, or it may differ only with phi star on the set f1x equal to c times f0x. So to see that let phi star be UMP alpha test, I again consider this delta x, which is phi star minus phi double star f1x minus c times f0x. Now let's look at this quantity. This quantity is either strictly positive, because in f1x greater than c times f0x, phi star x is 1. So it is 1 minus phi double star, which is positive, and this is positive. The way I just showed you, in the set f1x equal to c times f0x, this is anyway 0. And in the set f1x less than c times f0x, phi star is 0 by the part 1. So 0 minus negative. So negative, and this is anyway negative. So negative into negative, which is positive. So this would always be greater than or equal to 0. And this would be 0 under what condition? When either phi star x is same as phi star x, or f1x is same as c times f0x. And this would be positive only when both are non-zero. That means phi star minus phi double star is non-zero, and f1 is not same as c times f0x. Both should have it. And it is 0 on a complement. Let us consider integral over phi star minus phi double star f1x minus c times f0x. Now note that this is same as integral over phi star minus phi double star f1x minus c times integral over phi star minus phi double star f0x. Now note that both tests are uniformly most powerful tests. So their power has to be same. So that means under f1, expected value of phi star would be same as f2 phi star, because both are UMP alpha tests. So this is 0 because phi star and phi star have the same power. And you're talking this expected value under h1. And under h1, you know that expected phi star is the same as the power of the test. So this has to be 0. So that means this quantity is same as 0 minus c times phi star minus phi double star, and there would be f0 over here. What is this quantity? This is same as minus c times integral over phi star f0 dx minus integral over phi double star f0 dx. I know that this has exactly alpha by the construction, by the first part, because I've shown that this test is UMP alpha only when EF0 phi star is same as alpha. So this is alpha. And since phi star has a label alpha, integral of phi double star f0 would be less than or equal to alpha. So that means this quantity would be positive. C is positive and there's a negative sign, so this would be less than or equal to 0. So what does that mean? That means this integral is same as this integral over a plus integral over a complement. But integral over a complement, this is anyway 0. So that means just integral over a phi star x minus phi double star x f1 x minus c times f0 x dx would be less than or equal to 0, because this integral is same as integral over a plus integral over a complement. But integral over a complement, delta x is 0, which is phi star x minus phi double star f1 x minus c times f0 x. So that means this is only same as integral over a. So this means integral over a of this quantity phi star x minus phi double star x f1 x minus c times f0 x dx would be less than or equal to 0. But on a, I know that this quantity is greater than or equal to 0. That is what you have seen. Because this quantity is anyway greater than or equal to 0. So this quantity is greater than or equal to 0. So what does that mean? In fact, this is always greater than or equal to 0. So that means this set A has to be negligible. That means for almost all values of x, phi star x has to be same as phi star double star x. Or this quantity should be 0. That means f1 x is same as c times f0 x. So that means either phi star x is same as they match, or f1 x is same as c times f0 x. So that means the set where phi star can be different from phi double star is this set only, f1 x equal to c times f0 x. So this tells you a very interesting thing, that in general UMP alpha test may not be unique, but if there are more than two UMP alpha tests, they can differ only on this set. But if this set itself has a probability 0, or it is negligible, then the UMP alpha test has to be unique, because this has negligible weight, and UMP alpha test can differ only in this set. So that means if it is negligible or its measure is 0, then the UMP alpha test has to be unique. So this is what the next remark says, that if the set of all those x's such that f1 x equal to c times f0 x is negligible, then we have a unique UMP alpha test. Otherwise, UMP alpha tests are randomized on the set B, which is collection of all those x such that f1 x is same as c times f0 x. Then you can have a randomization over this set. So this is one thing. So UMP alpha test will be unique if this set, which is collection of all those x such that f1 x equal to c times f0 x, is negligible. Second part, there exists a UMP alpha test for which size is same as alpha, which is same as the level of significance. Now let me just make a small note over here. In some books, you'll find they also use the word most powerful test in place of uniformly most powerful test. Now note that why the word uniformly most powerful has been used is because your power function beta phi, beta f phi I think that is what I am using. Let me just see the notation so that, yeah, beta phi f, where f belongs to P1. So uniformly means, because power function is a function of f in P1, so it is minimized, power is maximum for every f in P1, for uniformly most powerful case. And that is why it says it is uniformly most powerful. For every f in P1, the power is maximum. But if P1 has only one element, or in other words, P1 is only simple hypothesis, then uniformly doesn't make much sense, right? Saying uniformly may be misleading because there is only one point. So what does uniformly mean? In that case, one may call it simply a most powerful test because power is only at one point, because your P1 has only one point. So when alternative hypothesis is simple, uniformly most powerful test is same as the most powerful test. So I drop the word uniformly when my P1 is simple, because there is power only at one f belonging to P1. So let's look at this example. My f0 is uniform 0, 1, f1 is uniform 0, 2. Suppose I have to test that f is equal to f0 against f is equal to f1. Now note that this test looks like a very trivial kind of a test because it says under h0 uniform 0, 1, under h1 uniform 0, 2. And you know that the sample observation which you'll be getting with probability 1 will be either between 0 to 1 or between 0 to 2. And since both are disjoint, if x is between 0 to 1, you can conclude uniform 0, 1. If it is between 1 to 2, you can conclude it to be f1. But that test may not have a level alpha. So to get alpha, I can try to use the uniformly, this Neyman Pearson lemma test. I know my data is, so I look at my phi star x would be 1 if f1x minus c times f0x is positive. Gamma if f1x minus c times f0x is 0. And 0 if f1x is less than c times f0x. Sorry, f1x minus c times f0x is less than 0. And there's gamma and c are chosen so that under f0 of phi star is same as alpha. That means probability that f1x is greater than c times f0x plus gamma times probability f1x is equal to c times f0x would be. So let us see, how can I write down my phi star? Phi star is 1. f1x is bigger than or equal to c times f0x. Now note that my f1x, so depending on what your x is, x can be anything from, I should consider only x between 0 to 1 and 0 to 2. So if x is between 0 to 1, then my f1x is 1. Sorry, f1x is 1 and f2, sorry, f1x is 1 by 2. So x is between 0 to 1 and 1 by 2. Both should happen, right? 1 minus 2, f1x minus c times f0x. So f1x is 1 by 2 for x between, minus c is also 1 over here, is bigger than 0. So that means c is less than half, right? So this will be 1 if x is greater, so c has to be less than or equal to half in this case. And if x is between 1 and 2, and f1x minus c times f0x. So for x between 1 and 2, f1x is same as 1 minus c times 0, because for x between 1 to 2, f0 is 0. So this is 1 So let me just again write it down. Yeah, so if my x could be between 0 to 1, if x is between 0 to 1, my f1x is, and this would also be satisfied. So that means 1 by 2 minus c is positive, x between 0 to 1. Yeah. Now, if x is between 1 to 2, then f1 x is 1 by 2 minus c times f0x f0x in x is 0, so this would be some issue somewhere. Let me just again go to the, let me just erase this and then. So what Neyman-Pearson lemma says, if you just go back to the Neyman-Pearson lemma, it says UMP4 would be of this type. Okay? There is UMP4 which is of this type. Yeah. So what would be my UMP4? What it says is yeah. So my UMP4 has to be of the type phi star x, which is 1 if f1x is greater than c times f0x. This would be gamma if f1x is same as c times f0x, and this is 0 if f1x is less than c times f0x. So I try to look at what is my delta x. Delta x is f1x minus c times f0x. Now, if x is between 0 and 1, x is between 0 to 1, what is my delta x? In x is between 0 to 1, f1x is half. And x is between 0 to 1, my f0 is same as c. If x is between 1 and 2, my f1x minus c times f0x turns out to be, for x between 1 to 2, f1x is still half, and this term. Okay? So note that this quantity f1x minus c times f0x is strictly positive only in the range x between 1 to 2. So in that range, it becomes 1 because f1x minus c times f0x is positive. Now this quantity, when x is between 0 and 1, so a choice of c is equal to half, a choice of c is equal to half may give me this quantity as 0. So I first consider the choice c is equal to half. Because c is equal to half, for the choice c is equal to half, this quantity becomes 0, which happens for x between 0 to 1, and then this quantity would be gamma. Right? So let me call this as a gamma, and later on we'll see that gamma is same as alpha. Now how I have to choose this gamma? So that expected value under H naught of phi x, you can call this as a phi star x, is alpha. What does that mean? That means gamma times probability under H naught that X lies between 0 and 1 plus probability under H naught 1 times probability that X lies between 1 and 2 is same as alpha. But under H naught, which is F naught, I know that X is uniform 0, 1. That means X lies between 0 to 1. So under H naught, the probability that X lies between 0 to 1 is same as 1. So this is same as gamma. Plus, under H naught, I know that X lies between 0 to 1. So what is the probability that X lies between 1 to 2? Yeah, what would be this quantity? If I've taken uniform, earlier I had taken uniform 0, 2, but now it is uniform 0. So this is under H naught, gamma is same as probability that under H naught, what is X between 0 to 1? This probability is 1 plus probability under H naught that X lies between 1 and 2 because under H naught,
0.
it is 0, right? So it is 0. So gamma plus 0 is same as alpha. So this means gamma has to be same as alpha. So this test turns out to be the uniformly most powerful test of size alpha. And what are the choices of C and gamma? C is half and gamma is same as alpha. So this turns out to be uniformly most powerful test. And that is, now one can consider similarly that F0 is uniform 0, 1 and F1 is uniform 1, 2 for testing F is equal to F0 against F is equal to F1, so that the following form is UMP alpha test. Gamma if X is between 0 to 1 and 1 if X between 1 to 2, where gamma is any quantity between 0 to alpha, right? So try to take this as a exercise. I may give this as one of the homework problems, but this again, you have to see what is delta X. It is F1X minus C times F0X, which is same as, again, X is between 0 to 1, because here your F0 union F1 has a support 0 to 1, union 1 to 2. So that means X is between 0 to 2. So when X is between 0 to 1, F1 is 0, right? So 0 minus C times uniform 0, 1, right? And when X is between 1 to 2, F1X is 1, uniform density, 1 upon B minus A, minus 0. So this is positive, right? Now this can be negative. Now if I make this to be negative, then I cannot achieve anything. So that means I can make C to be 0. I choose the choice C to be 0. Then this is 0 if X is between 0 to 1, and 1 if X is between 1 to 2. So my delta X is 0 in this case. So phi star X becomes gamma if X is between 0 to 1. And this is positive, so 1 if X is between 1 to 2. I want my size to be alpha, so expected value under H naught, phi stars would be same as alpha, so gamma would be same as alpha. So this would be so there is a test. So I can take gamma to be alpha. What is the power of that test? Expected value of F1, it would be 1, right? Power of this test would be 1 because under H1,
Yes, sir, 1.
power would be 1. In fact, in this case, you look at any gamma which is less than or equal to alpha. will also give you a power as 1 and it has a level of significance alpha, because expected value of phi is same under H0 is gamma, which is less than or equal to alpha. So in this case, the UMP alpha test is not unique, right? Because they can differ on this set. F1x equal to C times F0x. On this set, which is x between 0 to 1, they can differ any gamma may work, right? Because you want gamma to, that quantity to be less than or equal to alpha, right? So these are examples where again UMP alpha test may not be unique. So let me just stop over here. We'll meet tomorrow for our tutorial. So what I'll do tomorrow is I can take up a few of your doubts from your estimation portion, and then we can do some of these testing problems tomorrow to further clarify your doubts for better understanding of Neyman Pearson Lemma. So that's all from me for today. Any one of you who wants to stay back for clarifying your doubts may stay back. The rest may leave.
Sir, sorry, sir, I entered a can you please repeat which hall?
L13.
Okay, sir, L13. Okay, okay.
And I'll send you an email also, right?
Okay, okay, sir. Okay.
Okay.
Thank you.
Okay. Bye. Yes, anybody? Does anyone has any questions? Okay. Arkadeep, do you have any questions? Arkadeep.